Hey, this is an experiment to see if I can save this in Zoom where I usually use Kaltura. How I can upload it and see if I can get it to work for YouTube. First of all, this is one of the Generals figures 18. The other one is 19 for landing gear circuits. Um, And there are prepware questions that refer to if a wire is missing, what will cause something not to work. So what I'm basically going over is how does the circuit work? The first thing is with the lights that they have a little test circuit that it will have power always on these main wires here coming from the circuit breaker. If we push the light bulb in where the lens cover, it turns on, it tests the light bulbs for the red and the green. Go to our next one here. Basically, it works. There, it shows the power flow. And this is basically what happens if we have power always available on this circuit. But current flow is just what we're needing for something to happen, like the lights to come on. So in this case, we're really looking at the side here with the red light, goes down this wire here and goes and completes the circuit with if the left gear switch is not down. So if this left gear is in the not down position, it has a path to the ground. So by way of these wires, switch, it'll make the red light come on. If we have the left gear is down, but the right gear is not down, we still have another alternate path where power can flow and still get ground, and the light comes on. So if either the left or the right is not down, we get this, excuse me, indication. And so basically, we could have that one. And we can even have it to where it goes through this control valve. If it's not in the neutral position, um, then we have another pathway that we get ground, and the red light is telling us this isn't in the right position if we want the gear to be down. So that is just showing one pathway for showing that. This next one will use some of the same wiring. But basically, we're going down through the warning horn or speaker, and we're looking for this ground through one of our gear switches. And it is basically the same to where it goes through those, but it only takes one or the other throttle switches to be in this closed position, as in pulling it back to idle, that will cause it to have a full pathway through the horn to operate it through the throttle switch and to ground so that the horn operates. Again, it can also go through the right gear switch in order for this to happen. So we just need to understand what's going on with this one and basically how it works. If we want the green light to come on, it basically is having a path through that light, through the wire, and it has to go through the control valve in this neutral position, the right gear in the neutral position, and the left gear in this down position. So it has to have all of those met. If one of those is not in the right position, there's no way for power to get up there and find another path. So it's like an AND gate. All three have to be in that position to get the light to come on for green. Going to jump to the figure 19, which is also a landing gear circuit because it's very popular with the FAA. And we also have a green light, we have a red light, we have a test circuit for here, which is drawn a little bit differently. Just has the ground in common in the middle, And if we push the switch or push the light in, basically, we have a way to test the light and make sure it works. But normally it's spring-loaded to be in this position, that it goes around in a few different things. So let's go ahead and go to the next little slide here with some flow lines of power going through our circuit to simulate how we can get a green light to come on with the circuit. So basically we have flow lines going in through the green light and coming down wire 8 to the control valve switch, which needs to be in neutral. Then comes down this wire 7, and if our landing gear switch for the left side is in the down position and the right gear is in the down position, then we're basically able to get a pathway that we get a ground, and we can make this green light come on. So it's a little bit going on to make it go through this direction, but that's the way it should be to make it have a green light. And basically, that's what we're looking for on this one. Let's see if I can get the next one to operate. So for the red light to come on, it has to have a path to green. And basically, if the right landing gear is not down, then the switch is in this position, provides a ground directly to the right. But if the right gear is down, and the left gear on my right side is not down, then basically we can have an alternate pathway that it can still make the light come on. So it has to have one of the gears in the not down position to make the red light come on. So just wanting to know how this circuit works, we basically can have power also going to through the throttle switches to give us a warning that the gear are in the configuration that right here, that we have either the left gear is not down, or the next one, it'll be the right gear is not down. We have a way to get to the ground that will make the warning horn go off. So basically, the pilots are getting ready to land. They pull the throttles back to idle, at least one of those engines, which is enough that it thinks that means you're going to be landing. And so we have that pathway going to here and through the gear. If they're both down and locked, then there's no need for that warning horn to go off. And so we don't have a path for it to go off. There's the alternate path, just to show how that goes with the right gear switch in that position to provide a ground to make the horn go off. And so none of these drawings that the FAA has are perfect, as I would say with some of the other ones that I have looked at. I'm going to stop the recording there.